Hey welcome to my second weekly ramble about what I found interesting in the world of astronomy. So, first up, something that happened at the end of October was DESI, the Dark Energy Spectroscopic Instrument, had first light, which happened on October the 22nd. So, given it's now a couple of weeks into November, I think it's about fair to say that it's working alright and going well in preparation for formal observing early next year. So I think it's about time I gave the experiment credit. It's achieved that feat. What I'm very pleased about as well, I'll link to a white paper that talks about the design and setup of the telescope. And it talks of a time frame in that paper written in 2013 of 2018 to 2022 for the telescope to make its observations. So, for a complicated piece of kit, first light in 2019 isn't doing that badly. That's what it's aiming to do. To put it briefly, it's to help us find out about dark energy. For a slightly longer explanation, the universe is expanding, and that expansion is accelerating, which is not that sensible. You see, if all we have is matter and dark matter interacting under gravity, why is the expansion accelerating? You'd expect to pull the universe back in after an initial acceleration. Something that applies a strong negative pressure or repulsion would cause an acceleration of an already expanding universe. And our sort of quantification of ignorance, our giving a name to it and putting it in our formulas, is referred to as dark energy. Because it's dark, and energy would be a good name for what this is. It contributes to the energy of the universe. So we want to find out about it. We want to constrain what it's like, what it might be. And a good start would be to get a better nailing down of this accelerating expansion of the universe. And this is where this instrument, DESI, really shows its strength. You see, there's this thing called baryon acoustic oscillations. Baryons are basically the normal stuff in the universe, atoms, that sort of thing, but not free electrons, not dark matter, not dark energy, and not radiation. So the stuff that makes up stuff, like galaxies, that sort of thing in the universe. And acoustic oscillations are waves, and if, as accepted in cosmology, our whole universe was in a hot, dense state, then acoustic waves could travel through that, because it's sort of hot and dense. You can make acoustic waves travel through the plasma there. So that plasma that it's travelling through would tend to distort due to these waves, but then it cools down. And so as it's cooling down, the waves can no longer travel, but the universe still expands. And this gives us a measure of distance over enormous scales, as long as we can understand some cosmology about these oscillations. And once you use that to map out the large-scale structure, you then have a chance to constrain how the universe expanded and how that expansion accelerated over time. And that can constrain our knowledge of dark energy, rule out possibilities which predict a universe with a different structure, constrain the parameters in our equations on cosmology that depend on dark energy. So that's quite a serious thing that I found. There's also something quite funny that I picked up on. It's a crazy thing on Archive. So Archive is a repository of electronic preprints. What they are is essentially the electronic copies of articles that have not yet gone through peer review, but are basically ready to be submitted. There's some degree of moderation from Archive itself, and I saw a conference paper submitted for the annual conference on astronomical data analysis and software systems, or ADAS, which had the title Escaping from the Herd of White Elephants. Well, I guess I'm going to put that in, because if you've got a paper with that title, I'm probably going to have a look. They know how to get me interested. Okay, so a brief explanation of what I think happened here. Conference papers tend to be fairly short bits of academic writing which act as a record of what went on at a conference. If you give a talk, you write it up and you put that writing out to the wider world as a conference paper. It also makes it a lot easier for anyone who went to the conference or saw the talk to track things like your references, where you got your information from. But of course, not everything done at a conference is serious reporting of scientific talks. In this case, it includes a discussion part of this conference, which is referred to as birds of a feather. They're sessions of people who know the industry a bit, chatting. So Jan Nordum, Jan Grange, and Peter Turban had been tasked on writing up what has been described in the abstract as about 60 ADAS participants discussed the evolving role of users, developers and managers of astronomical data reduction software. Yeah, they had to write up, or they decided to write up this 60 people having a discussion. And it's one of them where it's got out there, but I'm not entirely sure they took it too seriously. So they say special emphasis was placed on the role of the user in the era of big data. Is it really inevitable that the increasingly ignorant user will just have to be satisfied with the standard products from data processing centres? So okay, there's a semi-serious point to this. Astronomical data reduction, basically turning the data from a telescope into something understandable, is vital, especially as new telescopes provide so much raw data. But while the telescopes keep getting better, there are some problems. What they say is data reduction software for producing these impressive results is scattered over several different packages, each with its own user interface and user support, and its own issues with installation and maintenance. All this makes the software increasingly difficult to use. So the way a lot of new telescopes do this is to have a data reduction pipeline for that astronomical project. A good example is the LOFAR array of telescopes has one, which is really useful because for massive data sets you need to do a lot of data reduction even before the amount of data becomes small enough for many people to handle at the end. So they have this sort of centralised data reduction idea from the start, but the conference paper or the discussion points out, however, therein looms a totalitarian hazard. Pipelines tend to be black boxes that will be even less responsive to user comments than the pioneering packages, which have profited so much from their active involvement. So the discussion then wanders in, could these data pipelines become white elephants, a colloquial term for an item where the cost of maintaining it far outstrips any usefulness it has, because the people who make that centralised pipeline may not be doing that much talking with the people who are trying to use the data, and they may struggle to find ways to make the data they're putting out the pipeline actually the stuff that the astronomers want. So they got some conference attendees to have an argument about it. I won't bore you with any more science, but I thought I would just pick out a few of the bits from the article that caught my eye. Perhaps, I suppose, made me suspect that this was a bit of a laugh in the end. About 60 people attended this BOF, birds of a feather, despite the fact that it clashed with drinkies at the end of a long day. We also have, unfortunately our audio recording failed us, so we have endeavoured to reconstruct the essence from our poor short-term memories. We'd also point out the article finishes with the line, as Ronald Reagan said, "You ain't seen nothing yet," and I can't think of a better way to finish than that. Goodbye.